Hi, my name is John.
And my name is Alice, and this is Math Videos for Parents. We help you so you can help your kids. Today we're going to be talking about polynomial multiplication. And I'm just going to dive right into the sample problem we have. When I learned how to do this, I learned the FOIL method. And FOIL is an acronym. It stands for first, outer, inner, last. So first means you take the first terms from each polynomial. So in this case, it's 3x and x. So 3x times x is 3x squared. And then outer is you take the outer terms from each polynomial. So it's going to be 3x and 4. So I'm going to say, okay, 3x times 4. Oops, let me write that permanently. Is going to give us 12x. Then we do inner. So that's our -1 there and our x. So -1 times x is -x, or -1x if you want to think of it that way. And the L in FOIL is last. So that's the -1 and the 4. So -1 times 4 is going to give us -4. Now I'm going to simplify this, but before I do that, I just want to mention that when I learned how to FOIL, I very quickly forgot what FOIL even stood for, and I just kind of learned this kind of by memorization, which has some disadvantages in that it doesn't really develop an inherent intuitive sense of exactly what you're doing. So let me simplify this, and then we'll talk to John about another approach or approaches we could take. So 3x squared, and then I'm combining common terms here. So positive 12x minus x is going to give me 11x, and then minus 4. So that's my answer. It's pretty straightforward, but again, there are going to be some disadvantages to foiling, which John is going to tell us about.
Sure. So when I learned how to multiply polynomials together, I also learned FOIL. But as a teacher, I came to understand how dangerous it is to use the word FOIL, and that when the problems became bigger, FOIL was no longer an option to use. And that also created a lot of confusion among students. There are two approaches we can use to multiply these polynomials together, and one of them is just through basic distributing. And the work that is done is identical to the work Alice did, but instead of saying FOIL and prescribing an order, we just treat it as distributive property. Students learn distributive property in middle school, and they understand that to be multiplying a term by each other term in the next set that's closed by parentheses. So by distributive property, I would do 3x to x, and that is 3x squared, and then 3x to 4, which is 12x. So that would be me distributing 3x to both x and to 4. Then I would distribute -1 to x, which makes -1x, and I would distribute -1 to 4, which is -4. So if you'll notice, we got out the exact same 4 terms, but we didn't use an acronym or a trick to help us figure it out. We stuck to the mathematical term of distributing in order to simplify the expression. So we have 3x squared plus 11x minus 4. There's also another approach that can be used that gels together nicely with earlier videos we made on partial products, and it's called using an area model. We can write out 3x minus 1 and x plus 4 using an area approach. We can make boxes up like we did with double-digit numbers and triple-digit numbers earlier, and we could treat each multiplication as finding the area of a rectangle that is created by multiplying those terms together. So for example, with the 3x times x, I look at that as sort of length times width. So what area would be created by multiplying 3x by x? And that would be 3x squared. Then over here, I multiply -1 by x. So again, length times width. -1 times x is -1x. Down over here, I multiply 3x by 4, length times width, and I get 12x. And then 4 times -1 for the last rectangle would be -4. Once we have all of our products, again, we notice that these are the exact same terms that we had when we distributed and also when we FOILed. So we just want to take some care to add up the like terms. So I have 3x squared, 12x minus x is 11x, and then I have the -4. So the area model offers a way to show it visually. I think this is good for beginning learners who want to understand the multiplication process when there's variables involved. But as the problems get bigger, I think using the word distribute is a better approach than using the word FOIL.
John, I could see that because I feel like in this problem, of course, we could FOIL or we could distribute or we could do the area model and they would all work. But in other problems, FOIL isn't the appropriate choice, but distributing in the area model, either one of those would always be an appropriate choice. So let's just use the technique that's never going to let us down.
That's true. And area has served us well all along. Like we perform multiplication in younger grades with the area model. Students learn it in middle school when they're distributing, basic distribution. And then when they get to high school, when they're doing problems like this, area can help us again understand all the different aspects of multiplication involved.
Right. I'm excited to try a problem. And hey, let's make it a hard one, right?
All right. Let's do a binomial multiplied by a trinomial.
Woo! Okay, so now I'm going to try the distributing method with this problem here. And this is a good example of why FOIL can fail us, in that we actually can't FOIL because we have a trinomial here. So, FOIL doesn't account for this middle term, things like that. So instead, we're going to use something that will never fail us, which is distributing, which is the technique John just showed us. So basically what I'm going to do, the order doesn't matter, just as long as you make sure to get every term multiplied by every term. So I'm going to focus first on this 2x, and I'm going to make sure to distribute it to every term in this trinomial. So I'm going to do 2x times 4x squared, and that's going to give me 8x to the third. Then I'm going to do 2x times -5x. Then I'm going to do 2x times 6. Next, I'm going to do this second term, and I'm going to make sure to multiply it by every term in the following trinomial. So -3 times 4x squared, -3 times -5x, and -3 times 6. Okay, now I'm going to gather like terms. So I scan left to right, and I only have one term that has an x to the third in it, and that's the 8x to the third. So that's just going to come down. Next, I gather up all the x squared terms. So I have -10x squared and -12x squared. So that's going to give me -22x squared. Now I have 12x and 15x. So it's going to give me 27x. And then I also have -18. So that is my answer. So, John, I can definitely see the advantage to that method. I'm curious to also try the area model because I think that's a bit more visual, and some people may prefer distributing, some people may prefer the area model.
Yeah, for sure. Let's move over to area next.
Wonderful.
Go.
Okay, so now let's do the same problem with the area model. And another good reason to know two approaches is it's just a really good way to check your work. So I'm going to kind of set it up here. And I'm going to make my rectangles. And this is just a nice visual way to make sure you're distributing every term to every term. So 2x times 4x squared, -3 times 4x squared, Negative 5x times 2x. Negative 5x times negative 3. 6 times 2x. And 6 times negative 3. And the nice thing about this is it perhaps makes it a little easier to gather like terms because they're going to fall in the diagonals. So you can see here are my x squared terms. And then here are my terms with x. So now I'm just going to combine like terms. So that's going to give us 8x to the third, and then negative 10x squared minus 12x squared is negative 22x squared. 12x plus 15x is 27x. My cat's here to help us. He's a fan of math as well. Minus 18. Wonderful. So we get the same answer both ways. And again, this way you can kind of pick which approach you prefer, and it's never going to let you down. John, I can see why you discourage the use of FOIL.
Yeah, because if we tried FOIL here, the negative 5x term kind of gets in the way, and we wouldn't really know how to handle that. And that's where all the incorrect answers will come in. So I think distributing an area model, as great as they were in the younger grades, are even more helpful in the upper grades in ensuring curricular coherence and continuity.
Wonderful. Great. Well, thank you very much.
All right. Thank you. And thank you for checking out our video. We will be posting some more. We do take requests, so please use our Facebook page to let us know about things that you might be interested in, or like us on YouTube. Leave some comments. We'd love to hear from you. Thank you.